going to talk about LLMs in AppSec. If only we had $1 every time someone said that, right? Okay, so my name is Vineeta. I'm from the Indianapolis area. Okay, no one disapproves that. Okay, that's good. Actually, I've been with Black Duck for around almost a decade, but my career actually started being an IT risk auditor, so it was pretty not fun. So then I figured I'll do something more technical, went back to school, got a degree in security informatics from IU Bloomington. And then I got a job with Black Duck as a security consultant where I did security assessments like source code reviews and pen tests and so on for different clients in the industry. And then I wanted something even more technical, and I ended up moving to R&D, where my wonderful team and I try to come up with innovative solutions that affect products all across Black Duck. We try to augment existing stuff. We try to come up with new things, just like a playground. When I'm not working, I'm pretty easy. I'll just do anything that'll get me out of the house. Even if it's just putting my cat on a leash and taking her out on a walk. Even in beautiful Indiana weather, yep, I'd love to do that. Okay, so large language models. I think there's a very big difference between AI, machine learning, and then large language models. So they are a type of AI systems that can understand natural language, try to break it up, understand what you probably need, and come up with an answer in that same natural language. So you remember the time when we would have to write like a little program and then hope and pray that it compiles into something that a machine can understand? It's actually very analogous to that. Except in this case, we just speak in natural language and the machine will try to break it up into something like vectors and then try to understand and assign statistical probabilities. I don't want to go into that stuff. And then try to guess what your appropriate answer could be. These are some words that people use to describe large language models. However, they really just are very contextual depending on how you use them and depending on how well you use them, actually. They can be true or not. Like, are they really independent? Are they really reliable? All of that just really matters depending on how you invoke the model or how you talk to the model. So if I were to explain a large language model to a 5-year-old, this is what I would use. An LLM is a super smart computer friend that has read all the books in the world and can answer questions. It can write stories, and it can guess the ends of your sentences. This definition is important because we will revisit it later in a different slide, and we'll see it in a different perspective. But for now, I wanted to talk about the fact that models aren't really like the latest and greatest right now. Some of the earliest work was done in, I think, 1960s in like a university lab. And the biggest turning point was maybe around 2010s, sometime mid-2010s, when Transformer came out. No, not Optimus Prime, the Google Transformer that helped companies try and tune and train their models much faster and more efficiently. So once that happened, it was just a rat race of who could build the biggest model with the highest number of parameters. I do not want to embarrass myself by trying to explain what parameters are, but usually the highest number of parameters, the higher the number of parameters, the more thinking capacity the model has. So as you can see, probably someone used this word, but it's the wild, wild west out there, or I should probably say here because we're in Texas. But just in like a few years ago, like 5-6 years ago, the parameters were in the billions, and now I think models like GPT-5 are rumored to be in the trillions. So models have had some great promising and successful stories in certain fields like content generation, for example. And no, I don't mean slop content like a cat trying to do lat pull downs, I don't know. But actual productive content where you can use your words better, like writing better emails, like writing better performance reviews. So in other words, things you probably don't like to do. So in those fields, it's shown some great promise. It's also done great with breaking language barriers, trying to bring people together in the world. For example, we can surely say that things like this won't happen, like the dish jerk chicken won't get translated to chicken rude and unreasonable, right? Models understand natural language. If you ask a tool and a model, what is jerk chicken? A model has the natural language understanding to know that, okay, they're not trying to translate this word by word, they're trying to understand what this dish is. So we're probably at that point and can reliably say that models have got that. Same with data analysis. Anywhere a lot of data needs to be looked at, we need to identify patterns like medical fields. I was just reading last week that models successfully helped researchers come up with a drug depending on some patterns in amino acids of a protein or something. So again, a good success story. But what is it about AppSec that what is so difficult or special about AppSec that everybody's just thinking, will it work, will it not work, or like why is there such a big debate, and why is it not so straightforward like the other fields? And that is because at the root of it, AppSec is relatively resistant to automation, and it lies at the center of context and consequence and complexity, the three areas in which LLMs struggle with. So fundamentally, there is some kind of mismatch between them. And it takes a lot of work, a lot of design, and a lot of coming together of pieces to make LLMs work for AppSec. LLMs are probabilistic in nature, which means they can look at data and at the most make an educated guess. So that doesn't sit well with AppSec because AppSec needs accuracy and AppSec needs exactness. It could take a single missed dependency or a single flag that an LLM overlooks to flip the switch of a vulnerability from a false positive to a true positive. So that doesn't work for AppSec. Models are also non-deterministic in nature, which means the same input will give you slightly different outputs every single time. Again, AppSec is a world of reliable evidence and reproducible results. And without that, it's hard for security sign-off processes to reliably use LLMs to, say, prove compliance. Models are also typically trained on static data. If not trained with static data, they're usually pointed towards static data, which means, again, they're not suitable for AppSec in the sense that AppSec is like always evolving. There are new risks out there. The threat landscape is always changing for a system. And if a model is not set up properly with that data, it won't be able to do what you ask it to do. Also, AppSec is a very high stakes game. It has very severe consequences. Like, how many of you here write code with the help of a coding assistant? Not code completion, but actually talking to a LLM and coming up with the whole functionality, right? It's very tempting to do that, right? We don't really want to waste our time on such problems. We want to use our brains on actual intelligent problems. But the thing is, a model will create like 300, 400 lines of code for something that could have been done in 10 lines of code. And we're not going to have time to review it. We just want to keep pushing features. And when we're in that stage, it could take a single missed secret that we didn't look at, or a single missed business logic flaw that could land us into a lot of trouble, like reputational damage, data breach, things like that. So again, it's very high stakes. The consequences are high. So it's hard to fully trust models when they evidently have proven to be too agreeable and non-deterministic. So it's not really a text generation problem like we saw in the previous slide. It's more about context, and it's more about judgment. So we need to ground ourselves in what AppSec still looks like today, like after 2 decades. We still want to find vulnerabilities very fast. We want to fix it reliably. Governance and audit has become very important, what with all the data breaches recently. Dashboards at one point used to be just pretty things with a lot of numbers for higher-ups to pull numbers from, but now alert fatigue is very real. AppSec teams are looking towards dashboards to understand what should I do next, or where should I focus all my efforts. Training and threat modeling, everything is too ad hoc, and it has to be added to existing processes and pipelines to have some real impact. And the first-class citizen of all AppSec issues today, supply chain. There's a lot of buzz around reachability, trying to understand like the whole dependency chain, and just trying to catch the bad, malicious dependencies. So if you were to approach this like with the mentality of, oh, you know what, I'm just going to prompt my way through it, I'm just going to chat with the model and try to fix all of these issues, it's not going to work. It's not as simple as that. You know, models are smart, but in order to actually use their power, you have to set them up for success. You can't just prompt your way through it. For example, models work on surface level tokens, which means when it's trying to scan a code base, it's probably not going to understand the semantic context on the get-go unless you explicitly prep the code for it, unless you explicitly point it towards the right sources. And you'll also notice that it'll probably crash and burn in actual realistic code bases, because code bases are big. It's probably not going to go through all of it and catch all the important stuff. Maybe some obvious stuff, but unless you do some sort of pre-processing, it's a very difficult problem to solve. Governance and audit, we spoke about how if there is no traceability, then you can't really use it reliably. Dashboards, we've actually had some success with that. If you throw some numbers at it, connect it to some good data sources and prompt it, it will actually give you some good actionable next steps. Developer training is interesting because it's like a trade-off game. Would you rather have the developer do 40 hours of training on top of their regular work, or would you have them use an LLM to learn on the go? So I guess it's more of a as-needed basis. Threat modeling, again, if you just use a single prompt approach or rely too much on the model, it'll maybe come up with some good abuse cases, maybe it'll scaffold tried and all that, but it's not going to be thorough, it's not going to be something that you can reliably use. Supply chain, again, just like with detection, it needs some sort of semantic data flow. So if I were to take all the critical AppSec issues and compare them with the actual capabilities of a model, this is what it would look like. In areas like training and awareness, documentation, triaging, maybe there could be some success because all of these need natural language understanding, interpretation of results, and summarization. But things like detection and remediation, if you think you're just going to prompt and say, hey, find vulnerabilities, it's not a problem of just using a single prompt. There's a lot more to it because it needs contextual reasoning. And things like runtime analysis, again, unless you set it up with live data, it simply doesn't have executional awareness. So let's look at some examples. Assume that you have a cloud network and say that you have a bunch of microservices set up on it, and you want to be able to identify an attack surface for this environment. You've commissioned an LLM, you've given it some architecture diagrams, you've given it some configuration files, the code of the microservices, what have you. Note how all of this is static. Now assume that one of the microservices is like an on-demand service that you spin up on a random port, right? That port, because it's random, a model can't actually map it to anything, and it'll probably think of that as just an outlier. So it's very difficult to be able to rely on such mappings that a model would do on static data. And this highlights the important problems of how using a model incorrectly without feeding it with the information that it needs, it simply won't be able to achieve its task. Let's take an example. Like, see, if you have like a debug microservice as part of this infrastructure that gets spun up when a different microservice goes down, for example. And the debug service is set up to just pick a random port and run on this network. The model doesn't know. It just doesn't know that that port could be active at some point. So if you were to help out this LLM, here's what you could do. You could try to give it the data that it needs by connecting it to something deterministic to gather the live data, like active scanning tools, passive scanning tools. Try to put it in the loop of, an LLM looks at data, comes up with results. If something changes, you run the scanner, you give it the results. But see, both of these can now work hand in hand, because if you were just running tools without an LLM, you've now ended up with tons of data, and someone from incident response will have to come in and use log queries and try to make sense of that data. But in this case, if you're feeding this data, especially through something like a RAG approach, where you can clean up the data and give it to the model can probably look at that port that got spun up at runtime, try to see where it originated from. It'll know that it came from something called a debug microservice, and hopefully it won't raise like a P1 issue. But in this continuous loop, if it does identify a port like 22 or 443, and it knows that this is a more high-risk port, then it has saved the engineer or the incident response team some time, and it can immediately raise a P1 issue. So the point is, unless we are using the models right, it's very hard to come to a conclusion that they probably won't work. The next thing I wanted to touch upon is this. Can someone guess what it is? I don't know. It's actually slop squatting. That's a squat. So I just wanted to touch upon slop squatting to emphasize on the fact that we may rely and trust models too much when we're trying to generate code that might end up in bad places. Slop squatting, maybe some of you have heard about it before, but I'll try to touch upon it a little bit. Someone in I think it was 2025, someone noticed that a model, when you ask it to generate a certain type of code, like for a certain functionality, it ended up suggesting dependencies that don't exist. And it was suggesting a dependency that doesn't exist like 30–40% of the time. So someone capitalized on it. Someone either too evil or too genius capitalized on it. They grabbed that dependency, which was being frequently suggested. They registered it with a package manager, created a fake package. And now when developers were trying to chat with the model with these coding assistants and generate code, this package made its way through the repo, and it was an easy into the code. So that is slop squatting. It's a take on the word typo squatting. So this highlights, again, the fact that we can prompt and say, hey, can you generate this code for me? But we rely and trust the model too much to generate safe code, where you've not even told it to generate safe code. Or assume that, we want to be safe, we want to talk to it better, and we say, hey, generate some secure code to do X, Y, and Z. This is even worse, because your prompt says that. Now you will trust the model even more that it'll generate secure code, and you're not going to review it. So it's, again, a combination of, it could be just a prompt game, it could be just prompt engineering. You could try some other things like adjust the temperature, try to, again, rely on some deterministic tools in the process, like SCA scanners. Maybe you can try to have a pre-authorized list of components, but we all know that won't fly. And you can always leverage the LLM's knowledge base before you actually accept the code. Try to do some homework on anything third-party that's coming into your code. Now the embarrassing part. I'm going to try and show some of my experiments in the initial stages when I was trying to use this single prompt or solo prompt approach to try and solve different AppSec needs that we had. So the very first thing that I did was try to use a model to come up with new SAST rules to also write those SAST rules. So what I did was I just pointed it to my SAST tool and said, hey, can you generate some SAST tools for this library? Again, it was too generic. I noticed that it just crashed. It didn't really understand the SAST tool very well. It just tried to come up with generic rules. It tried to hallucinate and guess the different ways that the tool works instead of actually analyzing the entire code and trying to understand the nuances of SAST. But it was good at generating like great test cases. It was great at like with the build and identifying errors and everything. It was pretty self-sufficient. But then what happened was that as it was trying to solve my problem, as it was trying to write these rules, I noticed that the combination of high confidence and hallucination was awful. Because when it's very confident, it'll make a tiny change and it'll try to build. It'll fail. It'll make a very tiny change. It'll again build. See, a human won't do this. So it became a very expensive task. So again, some of the lessons I learned was that it's always better to break up what you need from the LLM into multiple smaller modules. It doesn't even have to be something LLM-backed. You can even identify some things that are just pure automation. You don't really need the pattern recognition, for example, of a model. So that was one lesson I learned. I learned that I can connect each of these assistants to some tools. Tools, according to me, are just like a fancy way of saying, like, how we have utils in a repository that everybody can call and leverage? It's just like that. So I noticed that it's good to connect the minimum number of tools to each such small segment. I also noticed that it was very important to explicitly state what I wanted. Instead of just saying, hey, can you find some rules in the areas of, SQL injection, XSS, it was important to specify that, use this, just like a human would, use this strategy in trying to come up with this. Use this example to be able to write that SAST rule. Without explicit instructions, prompting a model is just like saying, hey, is sugar bad for me, right? It really doesn't have it's not going to produce any useful results unless you explicitly say what you need from that question. The other experiment that is currently ongoing is I'm trying to take results from a SAST tool. It was an idea from one of my colleagues. He said, hey, can you try to see if we can take one of these vulnerabilities and see if we can prove that it's an actual true positive by spinning up an exploit? Or the other side, can we prove that it's a false positive by proving that an exploit is not really possible? And then can we also prove that the fix we are suggesting actually works because the exploit will then go away? So you see, it's a very multi-stage problem. And like in the beginning, I thought, I'm just going to wing it. And I iteratively developed a prompt, and I figured, let it rip, let the LLM do its thing. And then I quickly learned that at least 50–60% of the time, it ended up creating fake exploits. Like it was just like console log saying, oh, look, I proved it, right? So it was clearly very deceptive. I also noticed that the kind of exploits that the model was coming up with were either too complicated or too simple. You see, when a human tries to come up with an exploit, when they're looking at a vulnerability, they will probably come up with something that takes least amount of effort and least amount of time, which means it's a very creative, critically thought exploit. And if the model simply doesn't have access to that sort of iterative exploit development, it's going to be hard for the model to come up with an exploit on its own. So again, unless you explicitly tell the model, hey, to prove this vulnerability, maybe you can think of these strategies. So unless you explicitly mention that, my results were bad. I also noticed that it was, even though it was bad with coming up with an exploit, something about critical thinking, it was pretty good with giving me some kind of a base, like a skeleton, that I could work off of. Like, it helped me debug my exploit. It helped me see what kind of dependencies were causing issues, things like that. It's still not great, right? Because you don't want a human to be called in unless we have something that's actually working. So some other lessons I learned in this was that, like in the previous slide, I split it up into multiple pieces. So I have a piece that actually does something like a recon. It goes out there and tries to identify, could this be an actual true positive? Try to do some kind of theoretical triage. I have a different piece where it would actually look at the results of this recon and try to come up with a report for the next model or the next agent, and then so on and so forth. I have like a agent that is geared towards coming up with an exploit. I have something else that will come up with troubleshooting instructions, things like that. As this got bigger and bigger, I learned that, I'm going to hit my token limit. The models are going to lose context. So I had to quickly learn how to manage context and try to orchestrate all of these agents to work towards a single task. It was also getting very costly because I needed to now focus on making sure that the model is not confusing itself by overthinking. So I built a supervisor agent that made sure that all of these work in a consistent fashion, that each agent produces a result that something downstream can use as well. So the bottom line is, unless you set up these models for success, they're not really going to give you ideal results. And when I say, it's pretty generic to say set it up to success, but what it could mean is that you could try to do some kind of data prep to make sure that it stays focused. You can try to rely on some kind of deterministic scripts and tools that will help it out. You can make sure that you have some supervisors and oversights in the process to keep it focused so that the data is flowing as you expect it to. You can have some templates on what the output should look like. And as always, it's pretty good to have a human in the loop somewhere. Not everywhere, but you can kind of identify what your appetite is and when a human needs to be called in. So if I were to go back to that graph and try to compare it with now like the wholesome approach where we are relying on some other smaller segments that are helping the model, we can theoretically expect that some of these areas will now have better results by using a model, like triaging and detection, remediation. We can expect some better results because now we're relying on some real data and not just training data sets of a model. And you can see that Mr. Ducky is happy now that Mr. Ducky in AppSec is happy because now agents and such wholesome approaches like a intelligence pipeline full of little segments is now helping someone in AppSec focus on real problems and make decisions based on data rather than actually doing the grunt work based on that data. Okay, I think, okay. So we're at the takeaway section, and I really wanted to revisit that original definition I showed you. Yes, LLMs are really super smart, but they're super confident. Yes, they've read all the books, but they've read the bad and the good ones. Yes, they can answer your questions, but they'll only answer based on what they know, which may not be always correct. And yes, they will write stories, but they will also deceive you and fabricate stories because they're very agreeable. And also, everyone is relying on models too much, and they want it to grow really fast and also not be expensive at the same time. So the reason I put this up is to show that if, like with any technology, if we don't work with the user manual of a technology, it's very hard to come to a conclusion that this is for you or not, right? So I'm going to take a break and pass the ball to you because I've been speaking for like 500 hours. So I'll show you some questions, and if you guess the answer, we have some black duck speakers if you want it. I know some people are minimalists, so no pressure. Okay, so the first question I have is, which of the following is not a typical mitigation for LLM hallucinations? Not a typical mitigation. RAG, temperature tuning, prompt engineering, increasing token limit.
D.
Correct. That's correct. Do you want to explain why?
Well, I mean, so RAG is providing more domain-specific knowledge, basically. Prompt engineering is making sure you're asking a question in a way that will give you a better answer. And then temperature tuning is basically adjusting the settings on your LLM so it's not doing something stupid. But giving it more money, it'll still give you a bad answer.
Yes, yes, thank you. That is very correct. Just to add to that, temperature, I don't know if I mentioned it earlier, temperature controls the, what is the word I'm looking for? It controls how creative you want the model to be. So if you want it to have a more random output, but also maybe more creative and intelligent output, you would then play with the temperature. Next question. LLMs can reason logically and apply common sense. Common sense, true or false? I was resounding. Anyone wants to explain the reason why? Yeah.
AI is a non-deterministic nature, meaning you will get a different response every time you answer the same prompt. Also, AI is just a summarization of the data that you stream from.
Correct, yes.
And if you tell an AI 1 is 1 equals 70, it's might tell you 1 is 1 equals 70.
Yes, we have seen a lot of data on that, right? Yes, it is. It doesn't really know what is common sense because it's just going to come up with, the best reasoning pattern that it found in that run. Okay, what is temperature control in LLMs? Oh no, I gave that away, didn't I?
Yeah,
That's the worst. Okay, I'll just skip that one. Increasing the number of parameters in an LLM always improves its accuracy. True or false? Yes, correct. Anyone wants to explain why? Okay, so it doesn't, because accuracy really just depends on the data set that it has been trained with. And no matter how much you play with the parameters, you will just make it a better thinker, but not an accurate thinker. Lastly, just an estimate around the room. How many models do you think are out there today, including all sorts of variations? That highest number that you've seen connected with models? Okay, that's too far. Everything out there. Yeah. Sorry, what did I say? A little lower than that, but actually it's like 10,000. Yeah, but that's the closest, I think. Yep, so around 10,000 plus models, variations, forks, everything out there. But the real unique ones are maybe like in the hundreds, and the proprietary ones are maybe like a couple dozen. Okay, here are some best practices that I have learned based on my experiments. Before you start trying to apply this intelligent ecosystem in your AppSec problems, first you probably want to ask, do I really need to LLM it, right? Maybe there are some ways that LLM simply can't help you. Maybe there are certain pieces that you can delegate to the LLM, but throwing a bunch of stuff at the LLM without some kind of prep probably won't yield you the results. It's always good to start slow with the prompts, try to come up with one output and try to build up from there and come up with like an overall system slowly instead of just bombarding the model with one big prompt. Always use, I talked about this before, instead of throwing a bunch of tools at each agent, for example, try to minimize it just so that they can stay more focused and the context is better controlled. Try to have a lot of quality checks along the way, because you'd be surprised how often a model can hallucinate and try to make up things as it goes, and you want to catch it sooner than later, otherwise it might just get too expensive. Have realistic expectations. Like if you had two individuals do the same pen test on the same application for the same time, I can guarantee that the results are going to be different. It's just how everybody thinks differently, and that's the same with the model. If you have like very high expectations to begin with, you're probably not going to be able to think in terms of what should be a standard. And some other like technical tips. At the end of the day, you might just figure out that it's just a game of coming up with prompts and a lot of data prep. It's very difficult to come up with the right prompt. I know that there's a lot of techniques out there like CoStar and everything, but unless you figure out how all of these pieces work together, AppSec things are a little difficult to solve. It's not straightforward, unless someone like my team is working on it where they've actually figured it out. So they're having a talk about this in the very next room after this, so please feel free to go check it out. Also try to encourage like a chain of thought process in your prompts. You can try to control how the model should think, just like how we would think. Try to solve this small problem and then try to see which decision tree to pick, right? You can try to control that in your prompts. Picking a model will probably just depend on cost. And yesterday we saw a talk about personality traits. Some models, I think there's no real testing framework out there to try to compare models per task. Again, that's a difficult problem to solve. But until then, I think we just have to keep testing and testing until we see that it meets our standards. Handling context. This is something that I really struggled with. And some people try to leverage vector DBs in order to handle that context before it's lost in that one run. You will see that you'll quickly run out of conversation turns, depending on the framework that you're using to bring all of these agents together. If you run out of turns, it'll truncate the conversation and you might lose some critical information, and then the LLM will just go in circles trying to solve the same problem again and again. And token limits, rate limits, all of these things are just normal software issues. Just like with any API call, you'll probably run into them. And until we finish all the water in the world, I guess we won't be able to get past them. I just threw these on there. I know we're almost at time, but some trends that are going on with LLMs right now. They're not really very AppSec focused, except I think there's one model that's apparently fine-tuned to cybersecurity called SecPalm. But a lot of focus is actually on trying to make models bigger. I don't know if they're getting better. I have to test them, but they're just getting bigger. Whether they're more suitable to AppSec or not, that's open to interpretation. There's a push for more open models, better open models. I think some people are working on trying to be more transparent and show the thinking process and the cost per computation metrics so that users can make an informed decision before they get sucked in, I guess. And legislation is trying to catch up, try to put a harness around these massive frontier models. With that, I think I'll try to wrap up and close by saying it's important that we start approaching this intersection of AppSec and models as not a model-centric system. It's not about the model. It's more about coming up with a system that works. It's about trying and testing and seeing which parts will actually work together to solve that problem for you. With that, I'll stop and take any questions. Okay, either that was too simple or it went way over your head. Great. No questions? Okay, so I guess we'll get a longer break then. Thank you.